question that comes up from time to time is the worksheet. A very straightforward question really, and one that should guarantee you plenty of marks, providing you take your time and don't make any silly mistakes. So here's our worksheet. All holes and tweenics to be filled with grain, storage factor 1.65 meters cubed. The stability data booklet provides the necessary data for the vessel. By completion of the worksheet and showing any additional calculations, get the GM, effective metacentric height GM, and the drafts. So we would go into the tables, our hydrostatic, our vessels tables, information, stability information booklet, and get the grain capacities. So it tells us that they're all to be filled with grain. So we fill in all the capacities here, divide by the storage factor, and that will give us the weights. Okay, so grain capacity obtained from the stability information booklet, divide by the storage factor, gives us the weights. To get the GM is km minus kg. So we have to find those two values. Well, our final km, of course, we would get from the tables from the hydrostatic particulars. The kg is simply the table weight kg moments. So these three columns here are the standard weight kg moment table. So there's the weight of cargo that we've loaded times the kg gives us the moments. The fuel and fresh water gives us the moments. We don't need to worry about the kg there because we've already got the moments. Very common mistake from students is to forget the free surface moments. So I just want to emphasize here, you need to transfer these free surface moments here into the vertical moment column. Very, very important. They must go into this column and be added to the vertical moments. Once you've got the total moments, the total weights in these columns here, you can get the final kg. The other common mistake students make is to forget to add in the weight of the vessel. So make sure you put the lightship of the vessel and the kg in here. So you've got then the total moments divided by the total weight, which gives you the kg. Okay, once you've got the kg, you can put it in the column here, look up the km from the tables, and that will give you the GM of the vessel. Then it asks for the drafts forward and aft. Well, the drafts forward and aft are the standard longitudinal problem. So in this instance, you have the weight that you've loaded times the LCG gives you the longitudinal moments. So these three columns here gave you weight kg moments, which we've just done, and then this column weight plus these two here give you the weight, LCG and moments. Obviously the free surface moments are nothing to do with this side of the problem. So now we added up all our longitudinal moments, again not forgetting the lightship, weight and LCG. Add up the total longitudinal moments, divided by the total weight will give you a final LCG. Then as long as you remember from longitudinal stability, you'd get your final displacement, go into the hydrostatic particulars, and you'd get your true mean draft, LCB, LCF, MCTC. So it actually indicates there the values you need to get out of the tables. Use those values in the formula to work out the trim. Standard formula to work out the trim forward and aft, and there are your drafts. Just one other point to mention, very, very important that you write the formulas down. If you hadn't written the formula down and say you'd used LCF instead of LCB, or you'd made a slight mistake here and just simply written the trim, you'd lose all your marks. But providing you've written the formula, you've shown the examiner that you know the relevant formulas to use. So then becomes a clerical error rather than a principal error. So always, always with stability, without exception, write formulas down. Every problem, always write the formulas down and then put the figures in below that. So reasonably straightforward problem, the worksheet. Just remember, of course, capacity, grain, divide by the storage factor, not multiply, divide, gives you the weight. kg from this one, LCG from this one, and then the standard procedure for working out the drafts forward and aft for a vessel. And here's the completed worksheet here. So as you can see, we've got the free service moments and moved them across into this table. We've not forgotten our displacement. Total moments divided by total weight gives us our kg 7.32. We've looked up the km from the tables, gm 1.07. Then we've got our longitudinal moments divided by our weight, gives us our new LCG. Gone into the tables with this displacement and got the values for draft, LCB, LCF, MCTC, written all the information in and got our answers. Now don't forget, as I say, I know I've not put it there, but don't forget to write the formula in to ensure that even if you make a mistake, you're still going to get most of your marks.